Okay, let's start. Hello everyone. In this session, we are going to learn how to find Fibonacci numbers, like how to find numbers in Fibonacci series where number can go as large as 10 raised to power 18. Okay, so we have to find Fibonacci of n. I think you already know what are Fibonacci numbers. There is a Fibonacci series which starts from 0 and each term is addition of its previous two terms. Okay, so you might already have learned how to find Fibonacci numbers using dynamic programming approach or just traversing linearly. But when your number n can go up to 10 raised to power 18, then your normal linear solution will not work. So we have to think something in terms of logarithmic approach. Okay, so solving this kind of relations, or any general recurrence relation having linear dependence on its previous previous numbers, we have to use a concept known as matrix exponentiation. Okay, so first go to iPad screen and start. Okay, so what is matrix exponentiation? Okay, so you have a matrix m. Let's say your matrix is 1 2 3 4 5 6 7 8 and 9, and you have to calculate its, you have to raise it to power n. So one of the basic or naive solution is just multiply m n times. Okay, and you will get your matrix m raised to the power n. I think you already know how to multiply two matrices. If you have not, then it's not a good time to learn matrix exponentiation and all the stuffs like that. You have to first clear basic concepts like how to multiply two matrices, both in mathematical terms as well as how will you write the code. Okay, so matrix multiplication of matrix is like the prerequisite for matrix exponentiation. Okay, but how can we optimize this approach? Like, we don't want to go off n, we don't want to travel, don't want to multiply m times. So one thing we can do, if you have already learned about how to find a raised to power b using binary exponentiation, then I think you may have guessed it what I am trying to do next. Okay, so let's say you have to find m raised to power n. If n is even, then you will no longer need to find m raised to power n. You can just find m raised to power n by 2 and multiply it with itself. So m raised to power n is as similar as m raised to power n by 2 multiplied by m raised to power n by 2, and you will do it recursively. So m raised to power n by 2 will go for m raised to power n by 4 into m raised to power n by 4. Okay, similarly m raised to power n by 8 will go into m raised to power n by 4 will go to m raised to power n by 8 into m raised to power n by 8. Okay, but what happens when n is odd? Like, you have to find matrix to the power 13. So what you do, you just multiply your matrix m one time, and now you have to just find m raised to power n minus 1. Now this n minus 1 becomes a even number, and you just go and do same stuff. It will become m raised to power 6 into m raised to power 6. This will become m raised to power 3 into 3. Now again m raised to power 3 is odd, so you just do m into m raised to power 2, and then it again become an even number, and you can proceed further like m raised to power 1 into m raised to power 1. So this is the basic approach of matrix exponentiation. How will you find exponent of matrix a raised to power m or m raised to power n efficiently? And you may think, what about the complexity, how this is not linear? So you have already known, like, you have already if you have already uh, go and go and work around binary search solution, then in binary search also we take something of n length, then we divide it by 2, then again we divide it by 2. So this all the time division, when you are doing division by 2, then it works in log of n complexity. ठीक है? So this m raised to power n will also work in log of n. Okay, so now we are going to see the code of how to find m raised to power n efficiently. Okay, just give me a minute. Matrix exponentiation, yeah, here it is. I have to switch to max screen. Okay, now what have I done in this coding part? So this is just your code to multiply two matrices. This is the code to multiply two matrices. This is matrix multiplication code. I think you already have known how to multiply two matrices. You have an input of matrix A, you have an input of matrix B, and I have just defined a mod factor of 189 plus 7. Okay, n is your size of A matrix, and I have taken that both of the matrices A and B are of same length, same size, so both are of size n. I will make a new vector 2D vector C to store all the result of A and B. And I think you all know how to multiply a matrix. It is just elementary school mathematics. You go to every column and every row and multiply it with the column of another matrix and store the result in C matrix. Okay, so this is just matrix multiplication code. This part is interesting. This part is matrix exponentiation code, where you are given a base matrix B. In our case, if we have to find out m raised to power n, then m is your base matrix, and an exponent would be your n, like how raised you want your matrix to be. Okay, so first of all, what you are doing, you are making a result vector to give out what is the result of m raised to power n, and initializing your result vector as the identity matrix. Why we are doing this? Because if we have to find, if our exponent becomes 0, then it's definitely m raised to power 0 will become an identity matrix of m. Okay, so we are initializing it as identity matrix. And now here comes our logarithmic part. Here comes the main crux of the code. While your exponent is greater than 0, if exponent is odd, exponent mod 2 equal to 1 means exponent is odd, then you just multiply your matrix one time. What's your result? You just multiply it one time with the base matrix. Like if I have to find m raised to power 13, I just multiply with m one time, then I will decrease my exponent will become an even number. I just continue. Okay, when it is odd, I just multiply one time and I just continue, unless when it is even, then I have to multiply base matrix by itself, and then I will do my exponent divide equals 2. Like if I have to find m raised to power 12, then I will multiply base and base itself, so it becomes m into our base will become m square, and exponent will become 12 divided by 2 equals 6 again. Okay, let's see it again on iPad screen. So we are about to find m raised to power 12. Okay, then what can we do? 12 is odd, then m will become m into m will become m square, and our exponent will become 12 divided by 2 equals 6. basically we are doing n square to power 6, and these two things are the same. Okay, and at last we will return our result. This is the matrix exponentiation part. Okay, okay, now how are we going to find Fibonacci numbers with the help of matrix exponentiation? Okay, so Fibonacci number is a general sequence of linear recurrence relation, like f of n is equal to something multiplied by f of n minus 1 plus something multiplied by f of n minus 2, let's say, plus something multiplied by f of n minus 3. This is not Fibonacci relation, but this is any general recurrence relation. Okay, for if we talk about only Fibonacci, then Fibonacci is generally f of n minus 1 and f of n minus 2. So here a is 1, b is also 1, and c becomes 0. Okay, so for any general relation, any general linear relation, what we will do, okay, for any general linear relation, what is happening? Okay, it's not coming. Okay, so for any general linear relation, how can we solve this? So some things are base cases. Some base cases I already know f of, I already know f of 0, I already know f of 1, I already know f of 2. Okay, now if I want to know f of 3, then how can I write f of 3 in terms of matrix? Okay, f of 3 is just a into f of 2 plus b into f of 1 plus c into f of 0. So if I write a, b, c here, then f of, then I multiply both the matrices, then f of 3 is just a into f of 0 plus b into f of 1 plus c into f of 2. Okay, so we are playing something like that, and to multiply matrices, we have to make sure we are doing correct dimension multiplication as well. Like here matrix is of 3 cross 1, here also matrix is of 3 cross 1, then we have to make sure here the matrix is of 3 cross 3. To make it 3 cross 3, we have to add some more numbers. Here we will add 100 and 010. Why is that so? Because if you want to know what is f of 2, then f of 2 is 1 times f of 0 plus 0 times f of 1 plus 0 times f of 2. Like f of 2 is equal to, no, I think I have done something wrong here. Here is the wrong part. It's not f of 012, it's f of 210. So f of 2 is nothing but 1 times f of 0 plus 0 times f of 1 plus 0 times f of 0. So these 0 times are all 0 multiplied or something is already neglected. So f of 2 is f of 2, and similarly f of 1 is f of 1. So you know why I write 1 and 1 here and the rest are 0. So now this is our base matrix, and this is the matrix whose result we already know. We already know what is f of 0, what is f of 1, and what is f of 2. Okay, now if anyone says we have to find f of 4, then what we will do? We will just do f of 4, f of 3, f of 2 is equals to something a, b, c, 100, 010. And here f of 3, f of 2, f of 1, because the same reason f of 4 is equal to a times f of 3 plus b times f of 2 plus c times f of 1. F of 3 is equal to f of 3, f of 2 is equal to f of 2, the same reason. But did you notice this matrix we have already computed in the last step. We have already computed f of 3 here. So instead of f of 3 we are going to put this value at this place. So it becomes, it again will be written same, and it becomes f of 2, f of 1, f of 0. Okay, so can you see this and this are the same? It becomes f of a, it becomes a b c and the whole square, and rest all the things are equal. Rest all the things are same as before. So now you can notice a pattern. If we have to find f of 4, then we have to multiply our base matrix. Let's name it as base matrix. We have to multiply it 2 times. We have to raise it to power 2. Similarly, if we have to calculate f of 5, then we have to raise it to power 3. So if we generalize this thing, if we have to calculate f of n, then we have to raise power of this matrix. Okay, 1 0, power of this matrix n minus 2 times, and this thing we already know, f of 2, f of 1, f of 0 we already know. Okay, now this is for this relation. Like, this is not always 100% true that we have to raise power of our base matrix n minus 2. In Fibonacci case, this is n minus 1. Let me show how. So Fibonacci numbers are nothing but f of n equal to f of n minus 1 plus f of n minus 2. And we know the values of f of 1 and f of 0. So if we have to calculate value of f of 2, then what we will do? We will just do 1 1. So f of 2 is equal to 1 time f of 1 and 1 time f of 0. And this is correct. F of 2 equals to f of 1 plus f of 0. Now to multiply, to match the dimensions of matrix multiplication, we have to do f of 1 also here, and if we are doing f of 1 here, then we have to do 1 and 0 here, because f of 1 is equal to 1 times f of 1 and 0 times f of 0. Okay, so here if we have to find again f of 3 and f of 2, then we will just make it the same, and here it becomes f of 2 and f of 1. But again the same thing, f of 2 and f of 1 we have already calculated, so we will replace this whole thing by the f of 1 1 0 1 and f of 1 f of 0. Now you can see for f of 3 we need to multiply 2 times. We need to multiply our base matrix 2 times. So for f of n, we need to multiply our base matrix n minus 1 times. For 3 it is 2 times. For 3 it is 2 times. So for n it would be n minus 1 times. Okay, so the main crux of the concept is you have to find your base matrix, like which matrix you are going to multiply, and you have to find the exponent to which exponent you are going to raise it. So in the case of Fibonacci, the base matrix becomes this and exponent becomes n minus 1 if we are going to find Fibonacci of n. So what we will do, we will just raise our base matrix to power n minus 1. Now you can see how matrix exponentiation comes into picture. We will raise this power using matrix exponentiation method. So this will work in order of log of n, and here we already know f of 1 and f of 0. This is nothing, f of 1 and f of 0 are nothing but 1 and 0. So after multiplication of these two matrices, our result is f of n and f of n minus 1 matrix. Okay, let's say result of this multiplication is 2, 3, 4, 5 something. This is arbitrary and not the exact values. So f of n minus 1, this matrix becomes this becomes this. Then what is the value of f of n? The value of f of n is just 2 plus 3. All the first row things here, f of n is in the first row, then all the first row things will be summed up, and the value of f of n is just sum of first row. That will be your resultant matrix. When you sum the first row of all when you sum all the elements in the first row, you will get your Fibonacci of n. Okay, so I think the tutorial part is all about this, and we can now proceed with our code. Okay, so let's go to Mac screen, let's go to code. So I think we can proceed with my solution only. Okay, so here is our matrix multiplication code. This is same as we have discussed before. Here is matrix exponentiation code. This is also the same as we have discussed before. Now here we have taken the input n, for which I have to find Fibonacci of n. If n is 0 or 1, this is just the base case. If n is 0 or 1, you will just return n. Like if n is 0, you will return 0, and if n is 1, you will return 1. Now you are calculating, you are making your base matrix. What was your base matrix? Your base matrix was nothing but 1 1 1 0. Okay, I made something mistake here. It's not okay. No, I'm sorry. I think I have made some naming errors. This is not your base matrix. This is your matrix final f of 0 and f of 1 matrix. So we were having these two matrix. One matrix where we have to raise it to exponent n minus 1. This is that matrix. 1 1 1 0 is that matrix. We have to raise it to power n minus 1, and this is the final matrix, like f of 0 and f of 1. So you may think that was just 1 and 0. Why extra 2 zeros, and why you have made this of size 2? Okay, so in order to, like here I have assumed that both a and b are of same size. Then in order to multiply them, I have made our base matrix of size 2 to match with our matrix that has to raise power n minus 1. So you can also make little changes in matrix multiplication code and adjust the code if the size of both the matrix A and B are not equal. In that way also the same thing works, but adding 0 and 0 will not affect, because you are just multiplying, and multiplication with 0 will not affect your result. Okay, now what you will do, you will just raise matrix B to power n minus 1, and let's say that is our result matrix. Then you will just multiply result matrix to your base matrix, or the matrix computed of the values you already know, f of 0 and f of 1. So your range matrix becomes something. And to find Fibonacci of n, to find your answer, you have to go to the first row, because only the first row represents Fibonacci of n. You have to go to the first row and add all the elements in the first row, and we have to print it with modulus 189 plus 7. So I have defined a mod of 189 plus 7. You just take the mod and you just see out your answer. So this was all about finding Fibonacci numbers in order of log of n using matrix exponentiation method. Thank you. We will meet in the next set of lectures. Till then, keep learning, keep exploring.